Welcome back. We're continuing to solve systems of linear equations by graphing. And when I say we're solving them by graphing, I use that term loosely, as we should know by now. So let's take a look at this. We have the system of linear equation given by x plus 3y equals minus 2. And 2x minus y equals 3. So here is our system of linear equations. We can call this line 1 and line 2. Now, we're given a system of equations, they're both in standard form. Now, we can convert to slope-intercept form like we've been doing by solving both equations by y. We should be very familiar with this. But since we've learned other skills as well, let's go ahead and use those. Here we'll graph the lines by finding the x and y intercepts of both of the lines. We have other skills, so let's go ahead and make use of them. Let's use all our tools here. So let's start with line 1. We have line 1 given by the equation x plus 3y equals minus 2. So we want to find the x-intercept and the y-intercept of this line. So how do we do that? Well, recall that the x-intercept is where the line crosses the x-axis on the graph. In other words, where our value of y is 0. So let's go ahead and set y. Let's plug in 0 for y and solve for x. That'll give us our x-intercept. So we have x plus 3 times 0 instead of 3 times y equals minus 2. Those two terms cancel, so we just have x equals minus 2. So our x-intercept is minus 2 and 0. That's where our line crosses the x-axis when y is equal to 0. Now likewise, to find the y-intercept, we know that we simply plug in 0 for x and solve for y. Our y-intercept is where the line crosses the y-axis, or when x equals 0. So let's go ahead and plug in 0 for x and solve for y. So we have 3y equals a minus 2. We just drop that term. So we divide both sides by 3. We can do that in the same step to isolate our y variable. So we have y equals a minus 2/3, which means our y-intercept is 0 minus 2/3. All right, so we have our x and y-intercept for line 1. So let's go ahead and find our x and y-intercept for line 2. And we can go ahead and graph them at the same time. All right, so our line 2 is given by the linear equation 2x minus y equals 3. We want to find the x-intercept first. Well, we find the x-intercept by substituting in 0 for y. We set y equal to 0 and solve for x. So we have 2x minus 0 equals 3. Just drop that term and solve for x by dividing both sides by 2. Those two terms will cancel, so we have x equals 3/2, which means our x-intercept is 3/2 and 0. All right, let's go ahead and find the y-intercept. The y-intercept is where the line crosses the y-axis, or when x is equal to 0. So we have 2 times 0 minus y equals 3. Those two terms cancel. We want to solve for a positive y, not a minus y. So let's go ahead and divide both sides by minus 1. These negative signs will cancel. So we have y equals a minus 3. And we identify our y-intercept as 0 and minus 3. So we have an x and y-intercept for both lines. If you recall, we only need 2 points, a minimum of 2 points to draw a line. And so we have 2 points for both lines, just the intercepts. Let's go ahead and, let's go ahead and draw our graph here. There's our y-axis and our x-axis, indicating positive direction. And let's go ahead and see what this graph looks like. Finding the intercepts is actually a very useful way to graph a line. So let's go ahead and we're using the x and y intercepts to graph our system of equations. So line 1 goes to the point minus 2 and 0 right here, and the point 0. Oh, excuse me, that was incorrect. Minus 2 zeros right here, and 0 minus 2/3 is approximately right here. Let's go ahead and connect these two points with a line, making it as straight as possible. This line continues infinitely in both directions, and it's described by the equation x plus 3y equals minus 2. All right, so let's go ahead and graph the second line. The second line goes through the point 3/2, 0, and the point 0, minus 3. So we can go ahead and connect these 2 points, and we get an idea of where they intersect and how they relate to each other. This line goes infinitely in both directions and is described by the linear equation 2x minus y equals 3. Okay, now again, when we're solving systems of equations by graphing, we're not getting an exact solution. We can use tools that we'll find later on to find that the exact solution of this system of equation is indeed 1 minus 1. And if you notice, the graph of this only gives an approximate solution. 1 minus 1 is actually right here. So this is due to error in scaling and whatnot. This is a little bit off, but we're just getting an approximate idea of what's going on with this system of linear equations when we're graphing them. All right, so let's go ahead and look at a few more. We just want to get familiar with graphing them. We should be by now. Let's look at the system x over 3 plus 2y equals minus 1. And we're also given 4x plus y equals 0. Okay, so this is our system of equations. We can call this line 1, this one line 2, and we want to graph these 2 lines on a graph by using the x and y intercepts. So let's go ahead and find the intercepts for line 1. Line 1 is described by the equation x over 3 plus 2y equals minus 1. So we know that to find the x-intercept, we simply plug in 0 for y and solve for x. So we have x over 3 plus 2 times 0 equals minus 1. These two terms cancel, and we can isolate our variable x by multiplying both sides by 3. We can just do this in the same step. That cancels the denominator there, leaving only x on the left-hand side, and 3 times a minus 1 is a minus 3 on the right-hand side. So our x-intercept for line 1 is minus 3, 0. So far, so good. Let's find the y-intercept. The y-intercept, or where the line crosses the y-axis, is where x equals 0. So let's plug in 0 for x. 0 over 3 plus 2y equals minus 1. That just cancels out to 0. Let's go ahead and divide both sides by 2 in the same step, canceling those two terms and isolating our variable on one side. And y equals a minus 1/2. So we have the point 0 minus 1/2, and that's our y-intercept for line 1. All right, so not a whole lot to these. We're just using what we know to find the x and y-intercepts to graph these two lines. Line 2 is given by the equation 4x plus y equals 0. We know to find the x-intercept, we need to plug in 0 for y and solve for x. So we have 4x plus 0 equals 0. And this one's going to be pretty simple. We can divide both sides by 4, but if you divide anything by 0, it's just 0. So we can just do it as a formality, just show you what we're doing. Those two will cancel. That's the only thing we want. So x by itself equals 0. That just cancels. So we know that our x-intercept is the origin. We know that this line goes through the origin, and we know our y-intercept. Well, if we think about it, we don't really need to calculate our y-intercept, because if we plug in 0 in for x, well, y is just simply going to be 0, and that's also going to be our y-intercept, the origin. So it appears we have a problem with line 2, because our x and y intercepts occur at the same point, the origin, and we need a bare minimum of 2 points in order to graph a line. But don't get excited here, because we have other tools at our disposal. So let's go ahead and solve equation 2 for y. Let's go ahead and solve it for y and convert the equation into slope-intercept form. And I'll tell you why we're doing it in a second. So let's rewrite it. We have 4x plus y equals 0. And if we solve this thing for y, we do so by subtracting 4x from both sides, which will cancel these two terms, and we have y equals minus 4x. Okay, we know the slope in this form is the coefficient of x, which is just minus 4. So what we have here is we have a point, the origin, and the slope of the line. So we can actually graph this without 2 points. We just have a point and the slope. We know how to do this. We've done it before. So let's go ahead and graph these two lines. Here's our y-axis and our x-axis, indicating the positive y direction and the positive x direction. And let's just go ahead and we don't have to scale this thing too much. Okay. All right, so the first line, line 1, goes to the point minus 3 and 0, and 0 minus 1/2. We can go ahead and connect these 2 points with a straight line, as straight as possible anyways, and they continue infinitely in both directions. Both lines have a domain and a range of all real numbers, and this line is given by the equation x over 3 plus 2y equals minus 1. Okay, so far so good. All right, so let's go ahead and plot the one point that we know for line 2, which is at the origin, and we can use the slope to find another point. We know the slope of minus 4 is the same as minus 4 over 1, so we have a rise of minus 4 and a run of positive 1. So let's drop down 1, 2, 3, 4 places on the y-axis and go over 1 on the x-axis. And we have another point. If you want to, you can go ahead and figure out a third point just to help graph this thing if we need to. So let's go ahead and do that. From the origin, if we go to the left one, we go up 4. So 1, 2, 3, 4. Here's another point. All right, we can find points all day as long as we know the slope and 1 point. So let's go ahead and connect these dots with a line going infinitely in both directions and described by the equation 4x plus y equals 0. Okay, so we have our two lines, and we can see how they relate to each other and approximately, notice I said approximately, where they intersect. The actual intersection or solution of this system is 3 over 23 and minus 12/23, so almost minus 1/2 where this point is. It's just over to the right a little bit. So that's actually the intersection. It's actually pretty accurate when we draw this. So this is the exact solution, which we're not worried about now, but we're just getting a graphical representation of each system of linear equations. We have several tools in our bag of tricks. We can deal with any sort of equation. We can plug in a few points. We can use the x and y intercepts, or we can just use 1 point if we can't find 2 points, and then just use the slope. So lots of tools that we've learned, and we should be able to use them all by now. So I'll see you in the next video.